In this lesson, we are going to learn about the properties of metals and metallic bonds. Well, metal substances are made of metallic bonds, and the structure of metals consists of closely packed lattice. We are describing this picture right here, a positive ion. So here we have a positive metal ions, and that is being surrounded by a sea of free moving. That means it can be moving from one place to another place without changing the properties of the metals. It doesn't cause one metals to become a different metals. So free moving electrons, well, valence electrons to be exact. Sometimes we use a term called free flowing because the electron pretty flow from one place to another place. Now the free moving electron or valence electrons cause the metal to be good conductors of electricity and heat. Well, conductivity, basic thing about this, it was free moving from one place to another place. You can now take the electricity from one end of the submetals to all the way over here. It's just gonna move from one end to another end. And that's the beauty of free flowing or free moving. That electron will allow you to carry electricity or heat from one end to another end. Hence the term conductivity. And while this is happening, it doesn't change the properties of the metals overall. It still remains as gold or copper or aluminum, whatever the metal is going to be. It doesn't change the properties of that metals. And that's the beautiful thing, because now it gives us that flexibility. Well, now metals are malleable and ductile. Malleable means it can be hammered into different shape. That's why a lot of things made from metals has a very unique shape, because we can make into any shape of our choice. And ductile think of wire. Well, what's so important about wires? Without wires, we would not have electricity at all. Without wire, we would not able to carry electricity from one end or one place to your homes. So that's the beautiful part of metals. It is malleable and ductile. And the wire can be as thin as your hairs. And that allows you to make all this amazing electronics, including your phone, your computers, and your TV. So that's metal. Then metals also has a luster. Well, think of the term luster like shiny. Think of everything that you see that are made of metal. It has that luster. It has that shininess that you see, okay? And the closely packed nature of the structure make metals a good conductor, as we mentioned before, since energy can be passed from one place to another place, or one ions to another ions. But because they are closely packed together, the electricity can just jump from one end to another end very easily. Then lastly, we have something called alloys. Well, alloys are basically a mixture of metals. Most of the substances that we see in our daily life that look like metals are actually alloy, because pure metals are very unstable. Think of sodium, think of potassium. Both of them are very reactive. That's why they bond with another substance to become stable. The common stable metals that you see and values are basically like gold, copper, right, and aluminum. But a lot of the things that we see in our daily life that look like metals are actually alloys. By mixing different metals together, we make a very stable alloy. For example, stainless steel is an alloy that prevents corrosion. But pure metals are very corrosive, but stainless steel is not. Alloys are made from metals. They still have very similar properties. For example, they are still good conductor. They are still malleable. They're still ductile. But we can make it in a way that favor in our choice. For example, prevent corrosion. And of course, they will still have a free moving electrons around those metal ions. There are two types of alloys. One of the alloy is interstitial, which consists of small atoms filling the space between larger or bigger atoms, and this makes the alloy more rigid and less malleable than the pure metals. Well, this is great for construction, right? You don't want an alloy or a pure metals that's very malleable because it wouldn't hold the structure of your house. So this is great. For example, carbon is added to iron to make alloy steel, which is used in construction. Another type of alloy is substitutional alloy. And basically, in substitutional, think of the term substitute. You have similar size of metals that are mixed together. And basically, they substitute each other. For example, brass is made from copper and zinc. And the alloy density of substitutional alloy are about the average of the two density of the two metals. Like interstitial alloy, they tend to be less malleable, and that's a key characteristic of alloy. We are now able to control the properties of the surface of the alloy as well as making it more rigid and less malleable.